A wound. 2 edges of torn skin. A man presses a soldier ant. Mandibles open against the cut. The ant bites. The skin pulls shut. He twists off the body. The mandibles stay locked. The wound is closed. This is surgery. In East Africa, driver ant soldiers have been used as living sutures for centuries. The same mandibles that can strip flesh from trapped livestock, repurposed to stitch a human back together. Some carry the most toxic insect venom ever measured by science. Some trigger more anaphylaxis cases than bees. One collapsed an entire island ecosystem without stinging a single animal, and one has quietly colonized 6 continents without any venom at all. This is every ant species you should never disturb, ordered by what disturb actually costs you. A mound sits in an open field, flat-topped. Unremarkable, someone steps on it. Within seconds, workers surface, hundreds of them, synchronized by alarm pheromones flooding the colony. They climb anything warm, grip with their mandibles, and sting. Fire ant venom is unlike most insect venoms. More than 95% of it is piperidine alkaloids, solanopsins, not the watery protein cocktail you get from a bee. These alkaloids are cytotoxic, hemolytic, and necrotizing. They destroy cells on contact. Within 24 hours, every sting site forms a white, sterile pustule. For most people, that's the worst of it. About 20% of stings produce large local reactions, swelling, redness, pain that lingers. But the real danger is immunological. Researchers have identified 4 allergen proteins in fire ant venom, Sol E1 through 4. In a sensitized person, a sting can trigger AG-mediated anaphylaxis, not because the venom got stronger, because the immune system remembered it. The ant didn't change, the human did. And this species is still spreading. As of February 2024, the USDA expanded quarantine zones into new counties in Oklahoma and Tennessee. The confirmed colony in Sicily means Solenopsis invicta now occupies every continent except Antarctica. On the Schmidt Sting Pain Index, the fire ant sits at a modest 1.2. But pain isn't the metric that matters here. Frequency is. Proximity to humans is. And fire ants have both. But there's an ant whose venom is 20 times more toxic, and almost nobody's heard of it. A flat gravel clearing in the Arizona desert, a perfectly circular patch of bare soil, a single entrance hole. This is the nest of the Maricopa Harvester Ant, and inside this mound lives the most toxic insect venom ever measured by science. LD50, the dose that kills 50% of test subjects, for Pogonomyrmex maricopa venom, 0.12 milligrams per kilogram, intravenously in mice. That's roughly 20 times more toxic than honeybee venom. An estimated 12 stings could kill a 2-kilogram rat, and yet, on the Schmidt Pain Index, this ant scores a 3.0. Not the highest, not the top of the scale. Bold and unrelenting, Schmidt wrote. Pain lasting 4 to 8 hours, so the ant with the most toxic venom on Earth doesn't even top the pain chart. Toxicity and pain measure different things. One measures how efficiently the chemistry kills tissue, the other measures how badly it burns nerve endings. Under normal conditions, the Maricopa Harvester Ant isn't a lethal threat to a healthy adult. You'd need hundreds of stings. But step on that mound in Tucson, and those 4 to 8 hours of drilling pain will teach you what most toxic feels like, without killing you. There's only one ant that scores higher on the pain scale, and that ant's venom does something no other insect venom does. A worker the size of your thumbnail climbs a tree trunk in the lowland rainforest, Honduras to Bolivia. She's not aggressive. Foragers rarely sting unprovoked. The trigger is the nest entrance. Ground level. Step near it and the colony responds. 1 sting. Schmidt Pain Index 4.0 plus. The highest rating ever recorded. Intense, brilliant pain, Schmidt wrote. Like walking over flaming charcoal with a 3-inch nail in your heel, and it lasts 12 to 24 hours, not fading, not tapering. Peak intensity for hours, because the venom contains ponerotoxin, a 25 residue neurotoxic peptide that locks voltage-gated sodium channels open. Picture a door in a nerve cell that's supposed to flash open and shut, sending one pain signal at a time. Ponerotoxin wedges that door open. The signal fires again and again, and the door cannot close. Documented symptoms: uncontrollable trembling, sweating, tachycardia, edema, swollen lymph nodes, for 24 hours. And yet, no confirmed human fatalities from a bullet ant sting alone appear in the peer-reviewed literature. The most painful sting on Earth isn't the most lethal. The Sater Ma people of Brazil have worn gloves filled with bullet ants as an initiation rite for generations. They survive, every time. The sting is about pain, not about killing. But in Tasmania, there's a much smaller ant, where a single sting can end very differently. She's barely a centimeter long. She hunts alone. She can jump several centimeters in a single bound, launching at anything that approaches. In most of Australia, the jackjumper ant is a nuisance. In Tasmania, she's a medical event. Approximately 3% of the entire Tasmanian population is allergic to jackjumper venom. In that state, jackjumper stings cause more cases of anaphylaxis than bee stings. Of those with a documented allergy, roughly 70% will react systemically if stung again. Between 1980 and 1999, 4 people died in Tasmania from jackjumper stings, all adult males, all with significant comorbidities, but the deaths were enough to change public health infrastructure. Royal Hobart Hospital now manufactures a specialized venom extract harvested from live jackjumper ants and administers it as venom immunotherapy. A clinical trial called Javelin is currently evaluating how long that protection lasts. A single ant species, a single island state, and an entire hospital program built around one insect sting. Even the way the allergy works is unsettling. The first sting primes the immune system. IgA antibodies form quietly. The second sting triggers the cascade. Same venom, same dose. But now your blood is loaded with antibodies waiting for exactly this molecule. Not every ant on this list stings. The next one won't send you to a hospital. It'll hollow out the beam holding up your ceiling instead. Late at night. The house is quiet, and from somewhere inside a wall, a faint rustling. Not mice, not settling. Something is working in there. Carpenter ants don't eat wood. They excavate it. Their mandibles carve clean, smooth galleries through beams, joists, and wall voids. These are tunnels for living, not for eating. They prefer moist or decaying wood to start, but once they're in, they expand into dry, sound timber. The colony operates a dual nest system. A parent nest, usually outdoors in a stump, log, or dead tree, produces the eggs. Satellite nests move indoors, into wall voids and structural members, housing workers, larvae, and pupae. The damage is silent and it's slow. It takes years. But by the time you notice the frass, that coarse sawdust mixed with insect body parts piling beneath a wall. The beam above it may already be hollow. The sign most people find first, wood that sounds wrong when you knock on it, hollow where it should be solid. This isn't an ant that hurts you. This is an ant that hurts your house, for years, without you knowing. It's already inside the wall. And there's another ant that remembers when you disturb it. A column of workers stretches 30 meters across the forest floor, each one carrying a piece of leaf overhead like a green sail. They're not eating those leaves. They're feeding them to a fungus, Leucoagaricus gondylophorus, a species they've cultivated for an estimated 50 to 60 million years. Neither organism can survive without the other. Disturb this colony once, and it responds. Workers release alarm pheromones. Major soldiers, the largest caste, with mandibles powerful enough to cut human skin, rush toward the threat. Disturb it again, and something changes. Researchers have documented measurable behavioral plasticity in autocephalotes colonies. With repeated disturbances, the colony becomes more aggressive each time. It learns, not the individual ant. The colony, as a system, adjusts its threat response upward. Threaten the fungus garden, and you trigger the most intense defensive response. That garden is the colony's sole food source. 8 million workers, a queen that lives 10 to 20 years, and an underground chamber, full of the only thing keeping all of them alive. You're threatening a civilization's food supply. And the civilization has been farming longer than most species have existed. But some ants don't wait for you to reach the nest. Some come looking for you 2 meters away. That's how far a bull ant worker can spot you. Most ants detect intruders through chemical or vibration signals. Mermisha tracks you visually. She sees you approach, she turns toward you. She advances. When she reaches you, she grips with serrated mandibles, locks on, and stings. Not once. Repeatedly, each sting injects a venom cocktail, described by researchers as hyperdiverse, novel aculeotoxin peptides that target mammalian sensory neurons. Between 2 and 4% of people stung by Mermisha species experience an allergic reaction. In severe cases, anaphylaxis, bull ants are among the most ancestral ant lineages alive. There are no massive coordinated armies, no chemical call to arms. Each worker hunts alone. A self-sufficient predator with excellent vision, powerful mandibles, and a sting she'll use as many times as it takes. The oldest strategy in the ant world. And it still works. There's another ant that uses a different combination, teeth and acid, at the same time. A leaf nest hangs in a mango tree. Step under it, and the territory line is crossed. Weaver ants are among the most territorial ants on Earth, and their aggression isn't random. Studies have documented a nasty neighbor effect. Weaver ants are significantly more aggressive toward neighboring colonies than toward distant strangers. Neighbors are the real threat. Strangers are passing through. That aggression is chemically regulated. Octopamine, the insect equivalent of noradrenaline, modulates a worker's propensity to attack. The chemistry decides how quickly she escalates. And when she does, the attack is a two-part weapon. She bites with her mandibles, pulling the skin taut. Then she curls her abdomen forward and sprays formic acid directly into the open wound. The acid doubles as an alarm pheromone. Every spray calls more workers to the fight. Colonies can reach 500,000 workers spread across multiple trees, all connected by leaf nests sewn together with larval silk. These ants are so effectively aggressive that farmers across Asia and the Pacific use them as biological pest control, guarding oil palm, citrus, teak, and cashew plantations. The aggression is millions of years old. The decision to use it as pest control is much newer. But the ants coming next don't guard territory. They don't have territory. They ARE the territory. And they're moving. A fan of brown bodies spreads across the forest floor. The front line is meters wide. Behind it, 700,000 workers, advancing. Esatan Berkeley doesn't have a nest. It has a bivouac, a living structure made of worker bodies, locked together by legs and mandibles, forming walls, chambers, and corridors. At the center, a wingless queen. When the colony moves, the entire architecture disassembles and walks. The swarm raid is the feeding strategy. Workers flush everything from the leaf litter, insects, spiders, scorpions, small vertebrates caught in the wrong place. The raid front consumes whatever doesn't outrun it. And this raid creates an ecosystem. Dozens of other species have evolved to follow it. Ant-following birds trail the advancing front, picking off insects fleeing the column. Parasitic flies hover overhead. Myrmecophilic beetles ride inside the swarm. The army ant column is a moving city that generates its own ecology. Different Esseton colonies even avoid each other's recently raided zones, deflecting away to optimize resources, as if the forest floor has invisible boundary lines written in chemical memory. The raid isn't personal, it is a harvesting machine, and you're either in the path or you're not. Their African relatives, though, operate on a different scale entirely. 20 million. That's the upper estimate for a single Dorylus colony. 20 million workers, marching in columns through Central and East African forest and savanna. The soldiers have sickle-shaped mandibles designed for one purpose: grip and slice. When a driver ant bites, the mandibles lock, pull the body away, and the head stays attached, mandibles still closed. That locking bite is the same one from the opening of this video, a wound pressed shut by an ant's jaws. For centuries, communities across East Africa have used these soldiers as living sutures. The mandible that can overwhelm trapped livestock is the same mandible that holds a wound together until it heals. The popular stories get one thing wrong. There are no confirmed, peer-reviewed cases of Dorylus ants killing a healthy human. The real danger is to the immobilized. Infants, bedridden individuals, trapped livestock. If you can walk away. The ants aren't targeting you. They're processing the ground in front of them, the same way they've done for millions of years. They don't hunt you. They process you. There's a difference, and it only matters if you can move. One island learned what happens when you can't move away from an ant invasion. Not because of size, because of numbers. A hectare is about 2.5 football fields. On Christmas Island, in the Indian Ocean, researchers measured yellow crazy ant densities of up to 20 million per hectare. Not across the island. PER hectare. The ants don't sting. They spray formic acid, aimed at the eyes and leg joints of anything in their path. On Christmas Island, the target was the redland crab, Gecarchoidea natalis. Tens of millions of crabs, blinded, immobilized, dead, and then the cascade started. Without crabs clearing the forest floor, the understory thickened. Scale insects, which the ants farmed for honeydew, exploded in population. Honeydew flooded the tree canopy. Sooty mold grew on the honeydew. The canopy began to die. Scientists have a term for this: invasional meltdown. One invader arrives, destabilizes the system, and creates conditions that amplify its own impact and invite further collapse. The Christmas Island forest skink, gone. The Christmas Island pipistrelle bat, confirmed extinct in 2009. The ants weren't the only pressure, but they broke the system that held those species in place. One ant species on one island. Dozens of extinctions followed in a cascade. The yellow crazy ant's origin is still debated. Possibly West Africa, possibly Southeast Asia. Nobody's certain where it came from. What it did is well documented. And yet there's one more species on this list, one that doesn't sting, doesn't spray acid, doesn't bite hard enough to matter, and it might be the most dangerous of all. An ant from a colony in California is placed in a dish with an ant from a colony in Japan. They don't fight, they groom each other. These colonies are 9,000 kilometers apart, different continents, different hemispheres, and the ants recognize each other as nestmates. Linapithema humel, the Argentine ant, forms unicolonial supercolonies that span entire continents. Workers from the so-called large European colony and the Californian large colony accept each other without aggression in laboratory tests. By some definitions, this is the largest single superorganism on Earth. They cannot sting. Their bite is trivial. No chemical weapon they carry poses any threat to a human. And yet Argentine ants have colonized 6 continents, displaced native ant communities across California, Southern Europe, South Africa, Japan, Australia, and New Zealand. Every ecosystem they enter, they simplify. Native ants disappear. Seed dispersal collapses. In California, the loss of native harvester ants, displaced by Argentine ants, has been linked to the decline of the coastal horned lizard, which depends on those native ants as a primary food source. The most ecologically destructive ant on this list is completely harmless to you, personally. And that's the problem. You'll never feel the bite. You'll never see the pustule. You'll never hear the rustling in the wall. By the time the Argentine ant has changed your local ecosystem, the species that used to live there are already gone. 12 species. 12 different meanings of the word disturb. For the billet ant, disturbance is stepping near a nest entrance, and the punishment is 24 hours of pain that no painkiller fully stops. For the fire ant, it's touching a mound that triggers an entire colony to surface in seconds. For the carpenter ant, the disturbance happened years ago, and the beam is already hollow. For the yellow crazy ant, you didn't disturb it. It disturbed an island, and the island is still losing species. And for the Argentine ant, the one that can't sting, can't spray, can barely bite, the disturbance is invisible. Silent, global, the supercolony doesn't announce itself. It just replaces everything that was there before. The ant species you should never disturb aren't all carrying the most painful sting or the most toxic venom. Some of them carry something worse. A system so efficient, you don't notice it until everything else is gone.